right, let's take a look at another ICS 712. Last video we did, we monitored some DC current. Now we're going to do some AC current with it, okay? So in order to do that, I have a variac here. It's plugged into an isolation transformer. I have my load in series with the unit and a ground fault interrupter. And you can see that I'm only putting about 30 volts here on the desktop. So we're pretty safe here. So what I'm going to do is I'm going to zoom in here a little bit. Okay, so you can see that we have zero current in the flowing, and with that we have 3.04 volts on the analog pin. That's our voltage on the analog pin. Now I bought 5 of these units and they were less than $3, free shipping, so I doubt if they're real units. And the spec sheet says that at 0 volts or 0 current you should have 2.5 volts. But we have 3.04. Now some of the units came up back with 2.67 volts, and they're all different, okay? And then for a 20 amp unit, you should have a sensitivity of 100 millivolts on there, okay? So that could be off too, so we're just going to test that part. So we've got 3.04 volts, okay? And I'm going to put 1 amp through this thing, and then we're going to see how much the voltage goes up, okay? So we got 1 amp going through. It's 116, 115. So at 115, 104, so that's 110 millivolts, okay? So in the code, I'm going to put in 110 millivolts instead of the 100 millivolts. Now, to get my, and we do have one, I already put that in the code, and we do have my 1 amp here, and we have 102 there. It's fluctuating around a little bit. Now there's several ways to monitor the AC voltage. Now you can do a kind of a software filter. They have some filter programs you can use to filter the AC. You can use an RMS scheme there where you take and you chop up the sine wave. So you divide it up 100 times, and you take each value, each slice of the thing, and you square it, and then you add all those slices up, all the squares up, and you take the mean of that, which is the average. So you add them all up and you divide by that 100 or whatever you have, and then you take the square root of that. So that's your root mean square, okay? So you can do that with the code, okay? In this case, I just wanted to keep it simple. So what I'm doing is I'm just picking the highest voltage, okay? I'm just going to pick the peak voltage, and we'll go over the code with you too. And it's going to be in the link to the code is going to be in the description. So this is I'm picking up the peak voltage, and now the peak voltage, the RMS value is actually 0.707 of the peak. Okay. Now I didn't do that in this program. I didn't add that. I multiply by the 0.707, and I'm adjusting it with the sensitivity value there, the millivolts coming back. Okay. Now you'd probably be better off putting the 0.707 in it and then looking at your millivolts again. Okay, but it seems to work this way, and it should work for DC too, because the DC is going to be there. You know, that's going to be your peak voltage. Okay, so I got 1 amp on there, 1 amp over here, 1.02, 1.02, so it looks pretty good. And we'll go over and take a look at the code and see what I did on the code. Oh, another thing is these units are sensitive to a magnetic field, and I had it sitting right next to that the coil, the relay, and then when I turned the relay on, it would go up a few more millivolts. Okay. So I've got it raised up in the air now, and I'll have to move it somewhere else on the board or keep it away from any magnetic field, and maybe put it in a little metal enclosure or something, okay? Because it does infect it. So if I put that down there, it goes up to 120, see that? About 1.2, because it's sitting next to the coil there. So pull that out of there. So one thing to be careful with those is they are sensitive to any magnetic field. So we'll go over to the desk and we'll take a look at the code. All right, we have the code here. Like I said, there's a link in the description, and we just start off with, we include wires in our liquid crystal, and it's an I2C liquid crystal, and then we're going to have our analog pin 0, and then we have a peak value, and then the last peak value, and then last update time, and then update interval of just one second here, you know. And then in a setup, all we have is their serial begin, so we can use the serial monitor to monitor the voltages, and then we have the LCD start up on that. So here's what we do here. We have the sensor value is equal to the analog read, the analog pin. So we just reading the input on pin 0 there, and then if the sensor value is greater than the peak value, it compares the sensor value to the stored peak value, and then we update the peak value if the current value is higher. Okay, so we're just picking the highest voltage there. Okay, and then we have our time in mils here, and then if the current time is minus the last update time is equal to the update interval, which is our 1 second. Okay, and then we have our voltage here. We just figuring our peak voltage, you know, the peak value times 5 divided by our 1023. Okay, and then the float current. Now here's where we add our units that we calculated here. We have our voltage here on the analog pin, and then we have minus the 3.04, and the 3.04 is now that was, you know, it's supposed to be a 2.5, but ours is actually 3.04, and then this 0.110, you know, 110 millivolts. Now for a 20 amp unit, it's supposed to be 100 millivolts. Now what I should probably do is actually times it by the 0.707 to get from peak value down to the RMS value. Okay, because the RMS current and the DC current are going to be the same. Okay, but I did it here with the millivolts coming back. Okay, so now if I want to use this unit to measure both AC and DC current, what I'm going to do is I'm going to add the 0.707. Okay, and then I'm going to put it away at maybe a switch or something to eliminate the 0.707 so that I can get the DC current, and then once I put the 0.707 in there, this will change, and then it'll be good for the DC current too. Okay, and then when you want to do the AC, you just you know, maybe turn a switch on or something that puts the 0.707 back into the formula there. So but I'm just doing it here with the AC, and it's working out fine without the 0.707, and I'm just doing it with this sensitivity setting right here. Okay, and then all we do is we just we print the value of the voltage and the current to the serial monitor and to the LCD screen. And then what we want to do is, if the voltage drops, we want to be able to detect that, and we want to reset it. So here's what we're doing there. We're just going to reset it, reset the peak value to monitor the AC waveform right in here. Okay, so like I said, there's a link to this in the description, and this seems to work fine. It's easier than doing the RMS value or trying to put a software filter in there. But so seems to work good, and I might modify this so that I can have a switch to work on AC and DC. Okay, so if you're going to do it, probably put the since we're doing the peak voltage, you should probably put the 0.707 there, and then keep this. And then if the unit's real, it should be 100 millivolts here and 2.5 volts on there. So, but it works on AC, and I think this is a easy way to do it. So yeah, give it a try. And I'm not a programmer, so but this seems to work good. So talk to you later. Thank you.